Welcome to Chapter 3.7 lesson video. Today we're going to be talking mostly about cubic functions. But in this homework assignment, you're going to review all the different parent functions that we've done so far in those earlier chapters. And so I want to warn you that those are on there as well, but mostly we're focusing on a cubic function and some of the special properties that go with it. Okay, so basically today we're going to talk about how we can graph and transform cubic functions and what you need to do in order to do that, and sort of the processes involved. We'll do a couple examples. It should be a fairly short video. All right, so this is our generic parent function right here. F of x equals a outside of the parentheses and then x minus h cubed plus k. Very similar to our quadratic vertex form, except this is a cubic. A determines the direction. If our a value is positive, then what that means is it means that our cubic function is going to be increasing. What increasing means is that as we go from left to right, it increases, it goes uphill. If it is negative, then it's going to be decreasing. So that means as we go from left to right, it's going to be going downhill. So you can keep that in mind that once you find that point, it's going to be increasing or decreasing, going uphill or downhill. I'll talk about a couple ways to help you remember that. All right, the inside value, your h value, it shifts you left and right. A positive h value is going to shift you to the left. So positive h causes you to go to the left, whereas a negative h value causes you to go to the right. So just like the other parent graphs inside the parentheses, it's kind of an opposite movement. And then lastly, this k value on the end, it causes us to go up and down. A positive k value causes you to go up, and a negative k value causes you to go down. All right, so as we can see down here, this is our sort of generic basic cubic function, y equals x cubed. We don't have a vertex here. Instead, we have what's called an inflection point or a critical point, and it starts at 0, 0, like most parent graphs do. So we're starting at 0, 0. So we're starting right here at 0, 0, and you can see that on one side of the graph, it's going uphill. So when it's positive in front, like in this case, we have a positive x cubed, on the right side, you're going to go up. If it was a negative on the right side, you would go down. And then the other side of the graph, the other side of your inflection or your critical point is going to do the opposite. So we went up here. So on the other side, we're going to go down. It's kind of like two halves of a parabola. One goes one way, one goes the other way. All right, lastly, we're going to plug in 0 to get the y-intercept if we can. If not, we'll just plug in 1 point to the right of our critical point. All right, so we just have a couple examples that we'll do here, and then we'll do some more practice and see if there's any questions during our live class session. All right, so first one's first, we'll go ahead and we'll draw this. Our directions at the top say find the critical point, the y-intercept, and then sketch graph. All right, so we'll find our critical point. Our critical point is our inflection point, or that kind of that center point on the cubic. So in this case, since we have a -2 on the inside and then a -4 on the outside, the inside part is opposite. So it's a +2 for our critical point. And then the -4 is our y change, so that's -4. That one is an opposite. And then what we're going to do to get a y-intercept, so this is our critical point, so we usually say CP. And then to get our y-intercept, what we're going to do is we're going to plug in 0. So you'll plug in 0 for x, so that's -2 cubed. So that's -2 times -2 times -2 is -8. -8 minus 4 more is -12. So our y-intercept is at -12. Okay, so if we're graphing this, this is what it'll look like. I'm going to draw my my marks for those 2 points, so that way I know what I'm doing. So I go over 2 and down -4, down -4. All right, so that's my critical point right there. I'll go ahead and put a point right there. That's the inflection point where on one side I am going to go up and the other side I'm going to go down or something like that. And then I'm also going to draw a y-intercept. Now I'm going to extend my axes down just a little bit, and I'm going to say this is -12 for my y-intercept. And then here's what I'm going to do. On one side, I'm going to go up. So since this is a positive value in front, nothing there, so it's a +1. On the right side, I'm going to draw my graph heading up, like an up half of a parabola. On the other side, I'm going to draw the down half of the parabola, but I'm also going to make sure as I draw that down half of the parabola going this way, I come through and I hit that y-intercept. So I will do my best to draw the other half of the parabola. So it's like two halves of the parabola. On one side, on the right side, since it was a positive in front, we're going up. And on the other side, we go the opposite direction, which is down. All right, now there's something special we have to do with cubics. So when we had squareds, if we had a negative on the inside, we just, at that time we said, don't worry about it. It's not something we really need to worry about, because if I square a negative, it becomes positive. In this case, though, a negative, 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 so I'll write that down up here, a negative times a negative times a negative, so a negative times a negative times a negative, is still negative. So a negative cubed is going to be still negative. So what we can do is we can pull a negative out. So what we're going to do is we're going to pull a negative off of our x. We're also going to pull a negative off this positive 3. So if we pull a negative off the positive 3, it's going to become a minus 3. We're going to pull that negative to the outside and rewrite it. So we're going to rewrite this as y equals, we'll pull the negative out of the parentheses, and then that negative x is going to become a positive x, and a positive 3 is going to become a negative 3. So we pulled that negative out of that parentheses that's being cubed. We have that plus 2 on the outside, and now we can start graphing. Now, if you don't do that, you're not going to get the right, left, right shift. That's not going to be correct. And you're also not going to get your graph going the right direction. So this is a very important step. If you have a negative in front of your x here, you have to pull it out. I repeat again, if on the test you have a negative in front of the x here, you have to pull it out. You have to pull a negative off the other value in there as well. So basically these two switch, so that negative became a positive, and that positive became a negative, and we wrote our negative on the outside. We can now go ahead and identify our key features. Our critical point is at the point positive 3, comma 2. So the opposite of negative 3 is positive 3. But y is 2, and then our y-intercept we can calculate real quick. We're going to go ahead and plug in 0 minus 3. Negative 3 cubed is negative 27. Make it positive. It's now positive 27. Plus 2 is 29. So our y-intercept is 29. Okay, we can go ahead and draw our graph and mark up our kind of key points here. So we'll draw our graph. We're going to go right 3, up 2, and that's where we're going to go ahead and put our critical point. And then we're going to also plot our y-intercept at positive 29. Now I know my graph isn't nearly tall enough, so I'll just say this is 29, and remember that it's going to be a little off of scale. Okay, now I remind myself, I look back at my equation up here and I see there's a negative in front. So from my critical point, I know that I'm going to start off by going down. So I'm going to go down off my critical point to the right. So down part of a parabola. On the other side of that critical point, I'm going to go up. And I'm going to remember that as I'm going up, I have to hit this y-intercept here. So from here, I start to go up, making sure to hit that y-intercept. Now my graphs look a little bit funky, but you want to do your best to try and make sure that you keep that cubic shape, right? So kind of there's a critical point in the middle, and there's half of a parabola on one side and half of a parabola on another. If it gets a little messy, if it doesn't quite look right, take a second. You can erase, you can redraw, you can kind of fix it if you need. All right, now this last one, the negative is already on the outside, so we don't have to pull it out, right? The negative's already on the outside. There is a left-right shift and no up-down shift. So we'll go ahead and find our critical point. Our critical point is negative 1, comma 0. So we went left 1 and no up and down. Our y-intercept, we can calculate that real quick. We would plug in 0 plus 1 is 1. 1 cubed is 1, make it negative. So our y-intercept is going to be negative 1. We'll go ahead and we'll draw our graph. All right, so this time we went just left, negative 1. That's where that critical point goes. Our y-intercept we found to also be negative 1. So on the y-axis, we would go ahead and make that a negative 1. We'll go ahead and put a point there. We don't have to put a point there. And then since there was a negative in front, we know that we're gonna go to the right going down. And we see we already have our y-intercept there, so we know we're gonna go to the right down and hit that y-intercept. And then on the other side, we're gonna go the opposite direction. So I'll do my best to draw a nice cubic to the right. I'm going down, hitting that spot. And then on the other side, I'm going to do the opposite direction, kind of trying to mirror it, but in a flipped manner. All right, with that, you should have enough information to be able to try and get started on the homework assignment. There's a lot of graphs on there, not just cubics, so make sure that you refresh on some of the old graphs. On our tests, we can have cubics, we can have any of the old parent graphs, so you gotta be prepared for anything. All right, if you have any questions, please reach out. Otherwise, I hope you have a great day, and I'll see you in our next live session.